Okay, let's look at the next question. Question 8. A company launches a new phone. The company's profit each year will depend on the number of phones it produces, X. The company's profit for the first year can be modeled by the function p of x equal to minus 1.5x squared plus 10.5x minus 4, where p of x is the profit for the first year in millions of euros, and x is the number of phones in tens of thousands it produces in the first year. X is between 0 and 7. X is real. Find P0 and explain what it means in the context of the question. Okay, so P of 0 is just going to be equal to minus 1.5 times 0 squared plus 10.5 times 0 minus 4. So when you do that, you will just get minus 4. So you get 0 here, you get 0 here. So what does it mean? It means that if the company produces 0 phones, they'll make a loss of 4 million euros. Okay, next question then. Complete the table below to show the values of p of x for the given values of x. So all you've really got to do here is take 0, put it in here and here, take 1, put it in here and here, that's already done. Put 2, 3, 4, 6 and 7 in here instead of x and work out the values. So I have done that, and the values that I got are, so if I put in 0, we got minus 4. If we put in 2, should get 11. Put in 3, you get 14. 4 is 14. 6 is 5, and 7 is minus 4. So we have to plot these points now. So let's see, 0 is minus 4, so we're going to have a point down here. 1 is 5, so that's here. 2 is 11, so that is here. 3 is 14, so that's here. 4, 14 as well. 5 is 11, which is here. 6 is 5, that's here. And 7 again is minus 4. You just got to join these up then. Okay, you should end up with something like that. Hopefully yours is a little bit smoother than mine, but that's what we get. Use your graph on the previous page to estimate the range of values of x for which the company will have a profit of at least 6 million euros. Show your work on the graph. So 6 million euros. 6 million euros is here, so you got to come across here. And from here then we got to come down. Look at that value, and we've got to look at this value here. So I'm looking at here a range of about, let's say 1.1 up to 5.8. 1.1 to 5.8. So I'm going to say then that x is greater than or equal to 1.1 and less than or equal to 5.8. These are the number of phones they need to produce in order to produce a profit of at least 6 million. So it has to be equal to these values as well. Okay, so the profit of the company for the second year can be modeled by the function q of x equal to minus 1.5x squared plus 9.6x minus 3.5, where q of x is the profit for the second year in millions of euros, and x is the number of phones in tens of thousands it produces in the second year. This time x is between 0 and 7, x is real. Find q prime x and hence find the value of x for which will give the maximum value of q of x. So what we've got to do is differentiate this. So if we have q of x is equal to minus 1.5x squared plus 9.6x minus 3.5. So we have to differentiate. So bring the 2 down, multiply it by the minus 1.5, that's minus 3x, reduce the power by 1 to 1. Take the 1 here, multiply it by the 9.6, so that's just 9.6, reduce the power by 1, so that'll give you 0. X to the power 0 is just 1. If you differentiate 3.5, you'll get 0. So then it says, find q prime x, which we've done, and hence find the value of x which gives the maximum value for q of x. So the maximum value is going to be given by minus 3x plus 9.6 equal to 0. You let it equal to 0. So subtract 9.6 from both sides will give minus 3x is equal to minus 9.6, and then divide by the minus 3 will give minus divided by minus is plus, so you'll get 3.3 2. So it's 3.2. These are tens of thousands of phones. So the value of x is 3.2, and these are tens of thousands of phones. Okay, then it says, hence find the maximum value of q of x. So what will be the profit at this stage? So let's do that. Then we know our function is q of x, which is minus 1.5 x squared plus 9.6 x minus 3.5. So all we've got to do is do q of 3.2. So we're just going to put 3.2 in here. So it's minus 1.5 3.2 squared plus 9.6 3.2 minus 3.5. So when you do that, you just get 11.86. So it's 11.86, and these are millions of euros. Okay, so let's move on to the next question then. The profit for a third year can be modeled by the function R of x, where R of x is the profit for the third year in millions of euros, and x is the number of phones in tens of thousands it produces in the third year. X is real. The graph of R of x is shown, and x is between 0 and 6. So the first question is, at the start of the third year, the company receives 3 million in additional funding. As a result, the profit for the third year can be modeled by R of x plus 3. So it's just the profit plus an extra 3 million. From the graph, estimate R of 2 and hence work out the value of R of 2 plus 3. So R of 2 is just going to be, again, you'd use a ruler and you would just come up along here from 2 and then across here. It looks like 8, so it's just going to be 8, and this is the profit, so it's in millions of euros. Okay, and then it says hence work out the value of R of 2 plus 3. So we have 8 here, and then in millions of euros, and then R of 2 plus 3 is just going to be 11 million euros. You just add 3. Okay, the last question then is, on the diagram above, draw the graph of y is equal to R of x plus 3 for x between 0 and 6 using the same axis and scales. Okay, so all we've really got to do here is just take each value, add 3. So let's go to minus 4, minus 3, minus 2, minus 1. Take 1 is here, so I'm just going to go up 3. 1, 2, 3. Be around there. 2 will be 1, 2, 3, somewhere around there. 11. This one here is going to be 1, 2, 3 around here. This one is 1, 2, 3 here. This one here is 1, 2, 3. And the last one then is minus 4, minus 3, minus 2, minus 1, which is here. So you just got to join these up. Okay, so that's my graph there. Again, it's a little bit shaky, but hopefully you guys will be able to do it a bit smoother than that. And that's it for this question. Okay, let's move on to